Hello friends, welcome to this video, and in this video we are going to learn about linear regression and we are going to implement it in the TensorFlow framework. So first of all, we need to know what is linear regression. Linear regression is a very common statistical method that allows to learn a function from a given set of continuous data. For example, we are given some data point of x and the corresponding y. We need to learn a function between them that is called a hypothesis. In case of linear regression, the hypothesis is a straight line. That is hypothesis, that is x is the input, is equals to the wx plus b, where w is the weight and b is the bias. So w and b are the parameter, are going to be the learned parameter, the trainable parameter, or we can say the parameter for the model. Okay, all we need to do is to estimate the value of weight and the bias from the given set of data such that the resultant hypothesis would produce a least cost. The cost function we are going to use here is the mean square error. So mean square error is the difference between the real value and the predicted value. It's going to give us the difference. So what the difference between our real value and the value the model predict. For finding the optimized value of the parameter, that is the weight and the bias, we are going to use a gradient descent optimization algorithm. So let's begin toward the code. First of all, we need to import some libraries. We will import three libraries. First, NumPy for the numerical computation, TensorFlow, the framework in which we are going to implement the linear regression, and Matplotlib library for the visualization purpose. Next, we are going to seed the environment. Seeding environment help us in producing the same random number again and again. Seeding environment also help us in reproducing the same result on another system, which is necessary when you are doing some good or complex work, like in speech recognition and other tasks where you need reproducible result. Like if you are in a Kaggle competition where point difference also matters, so you need reproducible results. That's where seeding come. Now we will generate our data set. We will generate 50 data point ranging from 0 to 50, and then we add some random linear data to it, adding some noise to it. Okay, now we are going to visualize the data with the help of the Matplotlib library. So you can see the data point which we plot on the graph. Now we'll build our simple linear model. First of all, we are going to define the placeholder. First is going to the input placeholder, that is x, and the output placeholder is going to the y. Y will in x we will give the in x we will give the input value, and in the y we will give the true value of the output. Okay, now next we will declare the true trainable variable for the weight and the bias, and initialize them using the np.random.randn function. Next, the two hyperparameter, that is the learning rate and the training epoch. Now next we are going to build the hypothesis, that is this formula we are going to implement in the function using the TensorFlow. Then the cost function, that is the mean square error, and then the optimization algorithm which is TensorFlow already implemented for us, the gradient descent, in which we specify the learning rate. You can change the learning rate according to you. Next we are going to train it. So first here we have written the global initializer which will help us in initializing these two variables, that is w and b. Next we are going to initialize this session and run it for some specific number of epoch, that is here we will train it to 1000 epochs. Then we feed the data to the optimizer using the feed dict, and then we will display the necessary data. So you can see it is trained for 1000 epoch, and this is the cost value and the weight and the bias value. Now we'll look at the final value for the cost, the weight and the bias. So you can see final training cost is 6.307, final value for weight is 0.914, and for the bias is 0.79652. Now we will plot the result. So this is the line we have predicted, that this is the hypothesis. Okay, you can see that it's here the line is crossing most of the point. It's trying to optimize itself for the maximum number of points. If you give it more data, so it will try to optimize more. If you train it more, optimize more, again good result. So That's all about the simple linear model, that is the linear regression. I hope you will understand and get the content. So if you like this video, then I will hope you will subscribe my channel, like this video, and if you have any query, then please comment on the comment button. Thank you. Have a nice day.